Hello, physics students. Welcome to Thor's last day as your instructor. I hope you've enjoyed my instruction, my awesome explanations of things. I've really enjoyed talking to you. The last thing I need to cover, first of all, the day's date is April 10th. I believe is the date, April 10th or 11th, whatever. It doesn't matter. All that matters is the lesson. So what do I want to cover? I want to cover what actually happens with the flowing of charges and what voltage means. And typically, when we describe the idea of flow, we use an analogy, which is one of those fancy terms for, look, here's something else that means like something similar to this. That's what an analogy is. So if you look at these moving pictures here, you see that on the left side, you have what is supposed to happen in a circuit. But on the other side, you have the hydraulic analogy, which is using water and to show you how we have a potential difference. Starting with the voltage over here, you see it has high voltage. Oh, now it's got a low voltage. The tricky picture moved. Over here, you have a low pressure in the pump. It's not putting a lot of water in that pump. So you got a low potential difference here. You have a low speed of water going into this pump. But if we change it, you can see now I got high voltage, got a high potential difference. I now have a high speed of water entering into the pump, which has an effect on the flow of water. It changed again. See, with low difference, you have a lower flow of electrons of energy. You also have a lower flow of water through this system. Notice how it's doing not as much work on this turbine, the water-driven turbine. But when you kick it up, you see more electrons flowing, more charge, you have more current flowing. And then all of a sudden, you have more work being done here. Over here on this side, you have more work being done. The turbine spins faster now because you have an increase in the flow of current. And that's essentially the hydraulic analogy. With a low potential difference, you don't have as much electron flow. But when you have a higher difference, a bigger distance between positive and negative, you get more work done. So now, oh, look at that light bulb. It's so bright. And that water wheel, that turbine, it's going faster now. It's being able to do more work. So that is it for today. That is the hydraulic analogy. I hope you've learned everything. I really hope you've enjoyed having me as your instructor. I've looked at the next thing that's coming up, and it's a bunch of boring math. I don't have time for math. So until next time, see you later. Maybe I'll see you in the movies in my next big movie, Thor, and everybody else. See you later.